Hi everyone, in this video we are going to discuss this example. So we have a very huge problem, right? So let us discuss all these things one by one, then we will start the actual solution. So here we have two matrix spaces x1 d1 and x2 d2, two matrix spaces we have, and with the help of d1 and d2 they have defined a new matrix D. It is defined in this way, okay? Square root of d1 square x1 y1. x1 y1 are elements of first component, that means element of capital X1, right? And d2 is operated on x2 y2, elements from second component, that means elements of this x2, right? So in this way, with the help of d1 and d2, one new matrix is defined D. So let us discuss what is our task. We have to prove that if you have any sequence, or if we have any sequence xn of xn is a sequence in this x1 comma x2, that means having two components, getting it converges to p1 and p2 if and only if that x1n converges to p1 and x2n converges to p2. Component wise convergence should be there if and only if, that means we have to prove in a both ways, getting. So it will be a very huge task, since both ways, that means we will assume first part, we will prove the second part, and then we will assume second part, we will prove the first part. So this is our task, right? And they have given some extension also, one extension also given. So with the help of this result, or you can say information, you can say if we have x1 and x2 are complete matrix spaces, if x1 and x2 are complete, then x1 cross x2, that is also complete matrix space. This thing we have to prove. So let us start to prove all these things one by one, okay? So I will not waste my time and space in writing the given things, since all things already you have before you, right? First of all, I will prove that if and only if part. I will assume this sequence xn converges to p1 comma p2, and we will prove that x1n converges to p1 and x2n converges to p2, okay? So assume that, let me mention, assume that, what I am assuming, that sequence xn converges to p1 cross p2, sorry, p1 comma p2, my mistake, p1 comma p2 in x1 cross x2. So this thing I have assumed. Now I have to prove x1n converges to p1 and x2n converges to p2. So obviously I am going to use epsilon definition. So let us start with one epsilon. Let epsilon greater than 0 be given, okay? I have taken epsilon. So now I will use the definition of convergent sequence. We have this thing xn converges to p1 comma p2. So let me mention, we have xn converges to p1 comma p2. So by definition of convergence, we can write for above epsilon, for above epsilon greater than 0, there exists n belongs to set of natural number such that, I will use the definition of convergent sequence. Definition says d of xn comma p1 comma p2, okay? Xn converges to this point, less than epsilon for all n greater than or equal to capital N. So by definition of convergent sequence, I got this one. Let us go further. So what is value of xn? My xn can be written in this way. So let me put its value. So therefore, d of x1n comma x2n, right? Comma, what we have, p1 comma p2. p1 comma p2 less than epsilon. Actually, I should carry this condition everywhere, but I don't have much space to write. So that's why at the end I will mention, okay? So therefore, after that, we have to apply the definition of D. What is the definition of D? This one. So let me use this definition here. So definition says we should have a square root. Okay, I have written d1 square. So d1 is operated on elements of first component. So here we have x1n and the second p1, right? First component, plus d2 square. So d2 is operated on elements of second component, that means x2n comma p2 less than epsilon. So to remove square root, I will take square of both sides. Let us see what will happen. So d1 square x1n p1, right, plus d2 square x2n p2 less than epsilon square. Since I took the square of both sides, so square root is cancelled here and we will get square there. See, we are adding two squares and which are less than epsilon square. That means each of them is less than epsilon square. So therefore d1 square x1n p1 less than epsilon square and d2 square x2n p2 less than epsilon square, with this condition for all n greater than or equal to capital N. Okay. So already we have this condition, so I have written that thing here again. See, squares we have, so let us take square root of both sides, positive square root. So that's why, therefore, by taking positive square root, we will have d1 x1n p1 less than epsilon for all n greater than or equal to capital N, and d2 x2n p2, agree, by taking square root of both sides, square, okay, less than epsilon for all n greater than or equal to capital N. But see, this is definition of convergent sequence, so therefore we can say x1n converges to p1 and x2n converges to p2. Okay, just make a screenshot of it, then we will go further. So let us continue. Okay, see, this is definition of convergent sequence, so therefore I can write, therefore that x1n converges to p1 in x1 d1. Okay, yes, x1 d1, and x2n by definition of convergent sequence, and x2n, this sequence converges to p2 in x2 d2. So in this way we have completed the first part. Okay, so we had assumed that sequence xn converges to p1 comma p2, and we proved that component wise the sequence are converging. So now we have to prove the converse part. So let me write here, conversely assume that, so now I am assuming that x1n, this sequence converges to p1 in x1 d1, right, and x2n, let me write properly, x2n converges to p2 in x2 d2, right. And what we have to prove now, we have to prove the sequence xn, that means x1n comma x2n having two components, and it will converge to p1 comma p2 where in x1 cross x2 d. So now we have to prove the converse part. This thing we have assumed and this thing we have to prove. So obviously without epsilon we cannot do anything. Okay, so let us take one epsilon first. I am taking epsilon. Let epsilon greater than 0 be given. So this time we have two information, that first sequence converges to p1 and the second sequence converges to p2. So let us use the given information one by one. We have x1n converges to p1 in x1 d1, right. So by definition of convergent sequence we can write, for given epsilon greater than 0, but see epsilon already we have, so therefore for above epsilon greater than 0 there exists a natural number such that, okay, so let us use this space, such that, so by definition of convergent sequence what can we write, d1 x1n comma p1 less than epsilon for all n greater than or equal to capital N. See, here we have a metric d1, so that's why I have written d1 here, right. Instead of epsilon we can write epsilon by root 2. See, epsilon means positive, small positive real number, and epsilon by root 2 it's having a same meaning. So that's why definitely we can replace, or we can write epsilon by root 2 there. Getting? It is just for adjustment. So this is very important thing for us. So let me call it as 1. So in this way we use the first information. Let us use the second information also. What is our second information? We have the second information is that x2n converges to p2 in x2 d2 in the second matrix. So again we can write in the same way, getting for above epsilon we have, therefore for above epsilon greater than 0, there exists a natural number n. But see, the symbol n we have already taken. So let me call it as n1 and this is n2, such that d2 of which metric we have now, d2 x2n comma p2 less than epsilon for all n greater than or equal to n2. So here also I will do the same adjustment, that epsilon by root 2. This is statement number 2. Get it? So two important informations we have, but the problem is that we cannot use both statements simultaneously. The reason is the first one is true for n1 and the second one is true for n2. Do you have any solution on it? Yes, so we can take the maximum of n1 and n2. Then both of them will be true simultaneously. So let n0 is equal to maximum of n1 and n2. See, this is true for all n greater than or equal to n1. This is true for all n greater than or equal to n2. So if you take the maximum of n1 and n2, then both of them will be true. So 1 and 2 will be true for this n0 I have mentioned. Okay, so let us focus on what we have to prove. We have to prove xn converges to this p1 and p2. So let us start to consider that thing. So consider d of xn comma p1 p2, right? So our target is to prove it is less than epsilon, then we can say it is a convergent sequence and converges to p1 p2, right? So I will follow the definition of d. The definition of d says we should write a square root first. d1 square, d1 of what? Okay, xn first component. Okay, what is first component of xn? x1n. So x1n and the first component of this one, which is p1, plus d2 square. Okay, so d2 will operate on second component. What is second component of xn? This x2n. And what is second component of this one? p2. So this is equal to square root of, but see, we have already written here d1 x1n comma p1 less than this epsilon by root 2. So this thing we can use and we can mention less than. Okay, this is less than epsilon by root 2. But see, square is there, so we should write square, plus what about d2? d2 x2n comma p2 less than again epsilon by root 2. So epsilon by root 2. But see, the square is there, so I should write bracket square. And obviously both are true for n0. So for all n greater than or equal to n0. So let us simplify it. Square root of, if you take square, epsilon square, square of root 2 is 2. Here also epsilon square by 2. So root epsilon square by 2 plus epsilon square by 2, that means epsilon square root cancel epsilon. Okay, so finally we got that epsilon. Okay, just make a screenshot of it, then we will go further. So let me conclude here. Okay, so what is our conclusion? Therefore d of xn comma p1 p2, we got it is less than epsilon. It is strictly less than epsilon with this condition for all n greater than or equal to n0. So but see, this is a definition of convergent sequence. So therefore xn converges to p1 comma p2 where in x1 cross x2 comma d with this metric d. So in this way we have completed the first part, right? If and only part was there. So we proved in both ways. So let us go for the last part. So now we have x1 d1 and x2 d2 are complete matrix spaces. Okay, so this is given thing, x1 and x2 are complete, and what we have to prove? We have to prove that x1 cross x2 is also complete. To prove that x1 cross x2 with that matrix D is complete. So first of all, tell me, when we say the matrix space is complete, if every Cauchy sequence is convergent, then we say the matrix space is complete. So here also we should start with one Cauchy sequence. So let I'm taking any arbitrary Cauchy sequence of this metric space and I will prove that it's convergent. Okay. So let xn is equal to x1n, x2n be a Cauchy sequence. Okay, and what we have to prove? We have to prove that it is convergent, then we can declare it is complete, right? So here also I am going to use the definition, epsilon definition. So let us start with one epsilon. So let epsilon greater than 0 be given. So right now we have just one information, that is it is a Cauchy sequence. So by definition of Cauchy sequence we can write, for this epsilon there exists a natural number n such that d of xn comma xm less than epsilon for all nm greater than or equal to this capital L, right? So there is no more space to write, just make a screenshot of it, then we will go further. Okay, so now what will I do? D of, let me write d of, see xn can be written in this way, so I am going to write in the same way x1n, x2n. Similarly, that xm is also can be written in this way, that is x1m comma x2m, and it is less than epsilon. See, this condition should be carried everywhere, getting, but there is no more space on this board, so that's why I will write at the end only. When you write this proof or this solution in your notebook, you are supposed to write this condition everywhere. Okay, so let us go further. Now what will I do? I will follow the definition of D. The definition of D says square root should be there, d1 square. So d1 will operate on first component x1n and x1m. So x1n and x1m plus, after that d2 square is there. If you remember the definition of D, otherwise go back at the beginning, we have already written the statement. There we have mentioned the definition of D. I am following the same. D2 is operating on the second component, so that's why x2m, right, x2n, x1n, x2n and x2m, x2n and x2m, right, less than epsilon. But see, I don't like that square root, so guess what we need to do? We will take square of both sides. So I will take square of both sides, so d1 square x1n, x1m, right, plus d2 square x2n, x2m less than epsilon square. Okay, see, we are adding two non-negative numbers since squares are there and matrix are also there, and we are adding them, still their sum is less than epsilon square. That means each of them must be less than epsilon square. So therefore, so d1 square x1n, x1m less than epsilon square, and d2 square x2n, x2m, guess the next step, less than epsilon square. Guess the next step, guess, please guess. Obviously I will take square root of both sides. So therefore d1 x1n, x1m less than epsilon, and d2 x2n and this x2m less than epsilon. See, this condition I should carry everywhere. So this is for all nm greater than or equal to capital N, and this is true for all nm greater than or equal to capital N, right? But see, this is definition of Cauchy sequence. So that x1n is a Cauchy sequence in metric d1 and x2n is a Cauchy sequence. This is definition of Cauchy sequence in xd2. So therefore that x1n is Cauchy in x1 d1 and x2n is Cauchy in x2 d2. But see, initially they have mentioned that x1 and x2 both are complete metric space. Complete metric space means what? Every Cauchy sequence is convergent. So these are also convergent sequences. Let me mention, but x1 d1 and x2 d2 are complete. Okay, so these are complete metric spaces. So therefore that both sequences must be convergent sequences. Okay, just make a screenshot of it, then we will go further. So therefore I can write therefore x1n is convergent in x1 d1. See, this is a convergent sequence, that means it definitely it will converge to some point, and x1n converges to some a1. Okay, see, since that this thing they are not given, we are assuming, so that's why I have written same, and this will be true for x2n also, and x2n is convergent in x2d2, and that x2n converges to a2. I am assuming this thing, but see, just now we have proved if x1n converges to a1, x2n converges to a2, then or therefore I can write that x1n comma x2n will converge to what? a1 comma a2. Okay, in the first half of this example we have already proved this thing in x1 cross x2 comma d, and this is nothing but our sequence xn, right? This is nothing but our sequence xn. So we started with any Cauchy sequence, and what we proved, it is convergent. Therefore every Cauchy sequence in that matrix space is convergent, so that's why we can say it is complete. Therefore every Cauchy sequence is convergent in x1 cross x2 comma d, hence it is complete. Hence it is complete. So in this way we proved if x1 and x2 are complete matrix spaces, then x1 cross x2, that is also complete matrix space with given matrix D. So in this way we have completed this example. Make a screenshot of it, note down in your notebook, okay, and we will meet in next video. Thank you. See you.